Gives me great pleasure to be here today and to represent the over 1,600 engineers we have around the world building ArcGIS. So I'm going to share a little bit about what we've been working on. So when we build ArcGIS as engineers, we build it in generic components, but then we realize that functionality in a number of ways. We can build, obviously, our GIS applications. We can build mapping, lighter weight applications. We can build location-based service applications, very lightweight. And we can also use it to build GeoEnabled systems that John talked about earlier today. So what I'd like to do is just step through for the next few moments at the various capabilities that we've been working on and that you'll soon be able to get your hands on with the newer releases of the technology. GISs often start with content. Now, typically, that's been your content that you've loaded into your GIS system. But increasingly, it's often services coming from other data providers. And we have a whole host of services that we provide ready to use inside of your applications. And we've been adding new updated data to these services. And we've also been adding some brand new services. The OpenStreetMap is an example of one of these. When you've got your data in your GIS, you've got to make maps. Maps are how you tell the story of your work. And so with smart mapping, we've been trying to make it very easy for you to build fantastic, beautiful-looking maps with as little effort as possible, picking default color schemes, choosing the correct overlays that you would want to put in your applications. Story maps have been an incredibly successful product for us. We've got over 1 million maps now shared publicly using ArcGIS Online. In fact, there's over 3,000 maps created every single day and shared out to our users' users. And with story maps, we've released a brand new version which allows you to build truly immersive applications so your maps can really come alive and your stories can be told very effectively. Of course, we continue to work on mapping and cartography, and we've made a number of advancements here, even in allowing you to bring your maps inside of Adobe's Creative Cloud, so you can pull both these environments together, again, to help you get your message out more effectively. Data management is a central component to any GIS, and this data can be stored on-premise. It could be stored in files, it could be stored in big data stores, or it could be coming from you over services across the wire. All of these are supported inside of our editing and data management capabilities. For 3D, we've made a number of enhancements. Let's start with visualization. We are seeing an increasing number of GIS systems where it's 3D first. And these are very common here in the Middle East, as well as in the Far East, and we're starting to see that trend come to Europe and North America. And as these trends continue to grow, so the capabilities need to grow with them. So we've improved our smart mapping capabilities if you're working within 3D environment. And we've improved our city planning tools with a new dedicated application, which you'll be seeing a little bit more of later this morning. But any GIS is not just about visualization, it's also about analysis. And with 3D, you want to perform your analysis. And the nice thing about a lot of the analytics that we've been able to build in our 3D is it makes use of the 3D models that we already have loaded into the GPU. So we can get fantastic performance as we perform our analytics, because we're actually using the GPU to help us do the analysis for us. So let's move on to spatial analysis and increasingly data science. It's interesting that over the last few years, the data science term has really exploded, and everybody wants to call themselves a data scientist. Well, let's face it, everybody in this room has been doing data science for years. Spatial analytics is nothing more than data science. And we've made a number of improvements here. One of my favorite ones is the inclusion of Python notebooks directly inside of the the ArcGIS system. And we'll have a look at some demonstrations later this morning of that. It really opens up ArcGIS to a whole new class of developer and data scientist. Imagery is a very important data type for ArcGIS. And we set out a number of years ago to really build a first-class image workstation, image processing environment. And we continue to deliver on that with more capabilities on the server in form of our image server, as well as new capabilities inside of ArcGIS Pro. So you can take your raster functions now that you've been familiar with in Pro, and you can push these raster functions into the cloud, and then you can access them from anywhere, something that's really exciting. And all of this can be performed on huge collections of imagery. As John alluded to, real-time is very, very important. And with the increasing number of sensors that are available, gathering all of that information in real time, so we've had to build more of capabilities into our real-time analytics engine, whether it's working on huge volumes of data or vast amounts of data coming in real time. Our back-end servers can now handle that volume with some enhancements we've been making. And early next year, we'll be releasing a new hosted Internet of Things environment, which will scale very easily to vast quantities of data. And the scaling of that is handled by the system in the cloud. For field operations, we've been working on a couple of strategies. One is to provide a set of focused applications, as well as providing some developer tools to allow you to build your own applications to support your custom mobile work flows. Because we see one of the biggest growth trends in GIS is mobile GIS. The workforces are going mobile, and they don't just want a pretty picture in a map, they actually want the full capabilities of the GIS when they're out in the field. And the ArcGIS Runtime environment provides them just that. So that was a very quick look at some of the generic capabilities that the teams have been working on. But these capabilities are realized in applications and products that you use every day. We've got Enterprise for on-premise back-end operations. We've got Online for software as a service, where it's just ready to use. All you need is your web browser. We've got Pro, the professional desktop environment. And we have dedicated solutions built on top of these that really take these generic products and focus them to specific workflows. And of course, all of this is made available to developers through the various APIs and SDKs that we have. So let's take just a step through some of these products. ArcGIS Online, with its 4 releases a year, just keeps on getting better and better with more and more GIS capabilities just built into the platform, ready to use from anywhere within your browser. Coming in fact, just in a couple of weeks, is a brand new map viewer, which will allow you to experience some of the new user interface components that we've been working on as part of our JavaScript API. ArcGIS Pro continues to evolve, and the focus of the team has really been on replacing all the capabilities within ArcMap to make sure that you can transfer your workflows from ArcMap-based workflows over to ArcGIS Pro. And the team's getting very close to declaring victory on that transformation. But it's not just about adding exactly the same capabilities that they had in ArcMap in a new 64-bit 2D, 3D application. It's about providing innovation, things that have never been done before. The new utility network, parcel fabrics, these are all coming to life in form of ArcGIS Pro functionality. With the Enterprise, the team's been working on 2 main projects. The functionality that has been released in the summer with 10.7.1 and will be released in 10.8 is more about making it ready for really industrial, hardened deployments, making it very robust, making sure we've got good data recovery and backups, built into the platform. But the team's also been working on a project that's more forward-looking, containerization and microservices. And you'll start to see that rolling out next year when they release that in beta. All of that generic capability comes together with these solution templates. And we have a whole host of these available. And these really allow you to get started with our technology in a quick and easy-to-use manner. Finally, let's have a look at these GeoEnabled systems. So increasingly, we've realized that although we build very functional GIS software systems, a lot of our users want it more focused for their specific problem space. And so we've got a number of these that we've been working on. The first one I'd like to highlight is ArcGIS Indoors. It's all about bringing more efficient management of your workforces when they're working indoors. So we can do a survey of your building. We can then ensure that your devices are very well located inside of that building. And with good location, you can make better decisions about your workforces and your assets as they're being used on a day-to-day basis. It's very popular with large organizations that have large spread out campuses. Airports, for instance, is one of the use cases that we support. ArcGIS Urban is about having better management of the urban landscape, making better decisions based on, as John said earlier, science. Not feeling, but actually taking all the inputs in and running them through some analysis and ending up with better decisions, smarter cities. And finally, a new product that will be coming out in January next year, ArcGIS Mission. ArcGIS Mission is all about giving you situational awareness in the event that first responders have to go out and deal with a situation. This allows people in the field to stay communicated with each other. They can send messages. These messages can contain information about location, other information such as photographs, but it also allows the people in the field to be connected, again using geo messages, back to the back office operation or the command post. And we really see ArcGIS Mission as a critical tool for first responders, and that'll be coming out in January. So that just leaves me to say that the team is working very hard on a number of releases throughout the year. Each product has its own release cadence. Online and the developer tools tend to release 4 times a year. The enterprise and the desktop tools tend to release 2 times a year. But with every release, there's more and more innovation that's being put into the products. And next year is going to be no different than this year. So with that, I'd like to pass back to Narit. Thank you.
Thank you very much, Euan. ואנחנו עוברים לחלק הבא בתוכנית, שעוסק במפגש בין AI ל-ArcGIS. מרתק. זה מייצר הזדמנויות חדשות מאוד משמעותיות שלא היו קיימות בעבר. Esri משקיעה הרבה מאוד בטכנולוגיות החדשות בתחום הזה. Data Science, Deep Learning, GeoAI Solutions. היא הקימה בשנה האחרונה מרכז פיתוח חדש בניו דלהי, שזה מוקד עיסוקו. בנוסף, מפתחים שם בניו דלהי את הדור הבא של ArcGIS, שמבוסס על Microservices Architecture, כמו ששמענו מיואן. Rohit Singh, who is here with us today, is the Managing Director of the new R&D Center. He is an expert in all of these emerging innovative technologies. אבל רגע לפני שאני מזמינה את רוהית ויואן לבמה, אני אספר לכם שעולם ה-AI וה-Advanced Analytics וה-Data Science עושה שימוש בשרתים פונקציונליים של Esri. ה-Image Server וה-GeoAnalytics Server מאפשרים אנליזות מרחביות מתקדמות על Big Data. ה-Image Server עובד על רסטרים, ה-GeoAnalytics Server עובד על מידע וקטורי. והנוטבוק סרבר החדש, שהושק בגרסה 10.7, מאפשר סביבת עבודה לדאטה סיינטיסט למיצוי מידע. I would like to invite to the stage Rohit Singh and Euan Cameron. Thank you.
Thanks. Okay, so we're going to talk about spatial analysis. But the thing that Rohit and I really want to stress here is it's data-driven analytics. So all of the data types that ArcGIS supports, you can pull in to your analysis. And it doesn't matter if these data are sitting as files on disk, files in a big file share, files in a server, data coming from a service, it can all come into your analytic workflows. And we really think that ArcGIS is a premium platform for performing this, whether it's the desktop application, ArcGIS Pro, on the front end, or it's the number of servers that we have, each one specialized in performing a specific task, or whether it's the ability to connect to all of these data feeds and pull them seamlessly into your application. So if we have a look at ArcGIS Pro as a platform for performing data science, it has a very familiar user interface. You could use your normal ArcPy tools inside of geoprocessing. You're performing data science. It also has a new way of working with this in the form of the Python API embedded directly inside of ArcGIS Pro. And that gives you the ability to pull in third-party libraries like PyTorch and TensorFlow directly within the professional workstation. And you can also use ArcGIS Pro to perform deep learning. You use it to prepare the training data, which you use to train the models, but once you've got your models trained, you can actually execute them all from within the desktop. But increasingly, data scientists, they use Python notebooks, Jupyter notebooks. That's their lingua franca of their world. And we've had support for Python notebooks with our Python API for a year and a bit. But what was really exciting in the summer this year is when we released Python notebooks directly embedded inside of ArcGIS. Because that allowed us to not only include the Python API in third-party libraries, for the first time, we could pull ArcPy tools directly inside of the notebooks to provide a very, very rich environment for you to perform your analysis on. So I'd like to start talking about deep learning. And we really see deep learning, there's two parts to it. There's the learning part of deep learning, and then there's the consuming part of it. And so what I'd like to do, instead of me talking about it for too long, I'm going to pass this directly over to Rohit, and he's going to step us through some great examples of where you can, or how you teach a model, and then how you use that model to perform real-world problems.